6.2 Trigonometric functions. You were introduced to 3 trig functions in Math 3 last year: sine, cosine, and tangent, if you were in honors. The cofunctions of sine, cosine, and tangent are 3 new trig functions that you are going to see in the rest of the semester. We will be using the unit circle throughout the majority of this chapter and into chapter 7. Once in a while, we will come across problems where we will be forced to use our calculator. So we will also be discussing when do we use our calculator and the mode that your calculator must be in for you to get an accurate answer as far as degrees and radians go. So by now we have already gone over the unit circle. We have discussed the degrees and the radians, and that those are 2 different ways to measure a spot on a circle, where the actual location is the point XY, which give us our cosine and our sine. So we are used to these first 3. Sine is the Y value, cosine is the X value, and tangent is Y over X. Just a quick summary of how I get those, or how, not I get those, but how that's been discovered. If I draw, actually let me put in a circle here. So go away, little thing. Let me put in a coordinate plane. Now let me put in a circle. I'll try and get this as perfect as possible. Okay, that looks like a circle to me. Let's move the circle so it looks like it's centered at 0, 0. Okay, so good enough. If I want to know where that point is on my circle, just like we did when we created the unit circle, we made a right triangle. Well, this is the point XY. Well, how do I get there? I get there by moving so much on the x-axis and so much on the y-axis. And since we're dealing with the unit circle, we know our radius is 1. If this is my theta, sine, if we remember from our previous workings of the trig function, sine is our opposite side over our hypotenuse. Well, opposite is y and our hypotenuse is 1, so sine is y. Cosine is adjacent over hypotenuse. Adjacent is the x, hypotenuse is 1, so x over 1 is x. Tangent is opposite over adjacent. Opposite is y, adjacent is x, so y over x. To go from these 3 trig functions to those 3 trig functions, we use the reciprocals of sine, cosine, and tangent. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent is the reciprocal of tangent. So today when you are being asked, or in your classwork, your homework, you're being asked to find all 6 trig functions, if you know sine and cosine, you can then find all 6. So you will need to keep referring back to this until you get it down. You will also probably want to write this on your unit circle so you have it as a ready reference so you don't have to keep flipping through your notes. So let's go ahead and get started with this. We have several examples that we need to get through, and I'm only going to do this in one video. I'm not going to break this up into 2. Find the exact values of the 6 trig functions. Well, this is on the unit circle. I know it's on the unit circle because they're not telling me it's the terminal side of theta. So on my unit circle is the point -1, 5 and 2 root 6 over 5. This is my x value. This is my y value. As we just discussed, our sine and cosine come from x and y. So sine of theta is going to be the y value, 2 root 6 over 5. Cosine is the x value, -1/5. Tangent, we need to remember, is y, so 2 root 6 over 5 divided by x, negative 1/5. Sine and the cosine are simplified. There's nothing else I could do. But on the tangent, I'm dividing by a fraction. So I need to flip and multiply by the reciprocal of the denominator. So negative 5 over 1. The 5's then cancel. And I am left with negative 2 root 6 over 1, which is negative 2 root 6. So I have 3 of my 6 trig functions. I now need to find the cofunctions. The cofunction of sine is cosecant. And to find the cosecant, you take the reciprocal. So 5 over 2 root 6. Unfortunately, my denominator is not rationalized. You cannot have a radical in the denominator. So I need to multiply by radical 6, which then gives me 5 root 6 over, well, this is 2 root 36, which is 2 times 6, which is 12. If I could simplify 5 and 12, then I would need to, but here I cannot. So that's as simple as that goes. For cosine, its cofunction is secant. And I take the reciprocal of negative 1/5, so it's negative 5 over 1, so I get negative 5. And then tangent's cofunction is cotangent. And the reciprocal of negative 2 root 6 is 1 over negative 2 root 6. And again, I have to rationalize my denominator. So I end with the square root of 6 over. I already did the 2 root 6 times 6, and I got 12, so this becomes negative 12. I'm not going to go through that work for you again. So those are the 6 trig functions that belong to the point negative 1/5, 2 root 6 over 5. Example 2. Finding the exact value without using your calculator. This is so important, you guys. If you are taking a quiz, you're taking a test, and it says find the exact value, your answer will never be a decimal. On a quiz, if you give me a decimal answer when it is supposed to be a fraction, I'm not going to give you credit because you let the calculator do all the work for you. Good job. You can hit buttons on a calculator. I want to see, do you actually know where this is on a unit circle? Show me that you know where 11 pi over 2 is and that you know that the sine is the y value of that point. If I don't see work, I am not going to be giving you credit. Couple of ways you can do this. If you don't like working in radians, you are welcome to convert the radians to degrees, which is why we did go over that in 6.2. I don't mind working with the radians, but I do want to rewrite this so it's easier to read. 11 over 2 is the same as 5.5. 2 goes into 11 5 times, which is 10 with 1 left. So 5.5. So 5.5 pi. So you need to get out your unit circle. I don't have a copy of the unit circle here, so get yours out. 5.5 pi. I'll draw a pretend one. Here's 0, here's pi, back to 2 pi. 5.5 pi. So watch. 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. And then I need half of a pi. So I am right here at 3 pi over 2. So 5.5 pi is the same as 3 pi over 2. How do I get that? Well, if I had changed this to degrees, it would be more than 360. So then we have to subtract 360. Well, the radian equivalent of 360 is 2 pi. If I subtract 2 pi, 5 minus 2 is 3.5 pi. Still too big. So I subtract 2 pi again, and I have 1.5 pi, which is 3 pi over 2. So at 3 pi over 2, the point is 0, negative 1. we need to remember that sine is the y value. So my point was 0, -1. So the sine at 11 pi over 2 is -1. This is the work that I want to see, you guys, whether you convert it to degrees or you leave it in radians. I want to see that you know 11 pi over 2 is the same as 3 pi over 2. And we'll get into the property, the periodic property in 6.3 about the 2 pi and the 360 degrees into more detail. B, I'm going to use the same circle here. B is the tangent of 6 pi. So 6 pi, if I start at 0, 1, 2, 3, 4, 5, 6, 6 pi is the same as tangent of 2 pi. I can start with 6 pi, subtract 2 pi, I get 4 pi. Subtract 2 pi, I get 2 pi. Okay, now I know where I need to be on the unit circle. It's the point 0, backwards. It's the point 1, 0. So this is for this one right here. 2 pi. Tangent is y over x. Here's my x, here's my y. So the tangent at 6 pi is 0 over 1, which is 0. Again, this is the work I want to see. Moving on. Sine of 90 degrees. Now this is easier. 90 degrees is on your unit circle. So please practice reading your unit circle like I've been going over with you in class. Use your finger, trace it around. What is the point at 90 degrees? Good. And sine, we need to remember the sine of theta equals y. So the sine at 90 degrees, the answer to this is 1. Now I have to add the tangent of 45 degrees. Well, the point at 45 degrees is root 2 over 2, root 2 over 2. We need to remember that tangent of theta is y over x. Well, this is actually easy. Y and x are the same value. So when I divide, when I have the same number, numerator and denominator, you get 1. So the tangent is 1. And 1 plus 1 is 2. The tangent of 45 is 1. Moving on, sine of 90 degrees. We just found that out. The sine at 90 degrees was 1, so 4 times 1. Minus 3 times, the tangent at 180. So go to 180, and what's the point at 180? -1, 0. Here's my x, here's my y. So remember, tangent is y over x, so 0 over -1, which is 0. So this is 4 minus 0, which is 4. Again, this is the work I want to see. You can use your calculator to check, but you have to make sure your calculator is in the correct mode. But this is the work that I want to see. And if your work is wrong and you magically get the correct answer because you used your calculator, I'm not going to be giving you guys credit. Do the work, please. All right, now we're back in radians. So they both have a pi over 4. So if you go to pi over 4 real quick, find the point, root 2 over 2 and root 2 over 2. This is my x, this is my y. So the sine is root 2 over 2. The cosine is also root 2 over 2. So we put a 1 underneath the 3 and the 2. Put a 1 underneath, multiply across. So I get 3 root 2 over 2 minus 2 root 2 over 2. Do not cancel the 2's here in this second fraction. You need a common denominator so you can add. 3 root 2 minus 2 root 2. That's the same as like a 3x minus a 2x. The root 2 is what tells you they're like terms, so we can add them together. And 3 minus 2, this is what I'm adding. 3 minus 2 is 1. So it's 1 root 2 over 2. So it's just root 2 over 2. All right. That's some practice using your unit circle. Let's move on. Example 3, find the exact value of the 6 trig functions. So I have 405 degrees. That's not on my unit circle. That's not in the 360 degrees of revolution. So I'm going to subtract 360 degrees. So when I do 405 minus 360, I get 45 degrees. Is that on our unit circle? Yes, it is. So go to 45 degrees, please. Go all the way around, find 45, and what's the point there? Okay, hopefully this is what you found. You identified it as root 2 over 2, root 2 over 2. So the 6 trig functions, sine, cosine, tangent, and then their co-functions, secant, cosecant, cotangent. Don't forget, you already have sine and cosine. So the sine at 405 degrees is root 2 over 2. The cosine at 405 degrees is root 2 over 2. Tangent at 405 degrees. And you could be writing theta if you want to. I'm not worried about you guys writing the 405, though you should. Don't forget tangent is y over x, and we talked about this already. These are the exact same, so when you divide, you get 1. Now to find the cofunctions, what do? Think back, we did this in example 1. Yes, we're going to have to take the reciprocal to find the other 3 trig functions. What goes with sine? Look real quick. See if you can remember what goes with sine. All right, so it's cosecant of 405 degrees is going to be 2 over root 2. Hopefully you recognize that you can't have that root in the denominator. So this is 2 root 2 over, the square root of 2 times the square root of 2 is 2. 2's cancel, and you're left with root 2. Now this is going to be nice. What goes with cosine? Hopefully you said secant. Well, this is also going to be 2 over root 2. Oh, we just did that one. And what did we get? Square root of 2. And then what goes with tangent? Everyone remembers this one. Cotangent. That's the easy one. And the reciprocal of 1 is 1. All right, let's continue forward through this. Let me see how we're doing on time. 17 minutes. Okay. I think I'll make this our last example. Instead of making one long video, I'll just go ahead and make this 2. So we're going to use a calculator. This is going to help us practice changing your calculator's mode from degrees and radians and vice versa. It's very important to know when you need to be in degrees and when you need to be in radians. The key is, oh look, that's a degree. We need to be in degree. Oh, that's a radian. We need to be in radian. So all calculators are different. We will go over this in class for your specific calculator. You have to find the mode button on your calculator. And then you're going to switch back and forth from degrees and radians. If you do need help with this, you're going to have to ask me in class tomorrow or come in and get some extra help on your own time. For me, I have to hit second mode, and then I have to switch mine to radians, or in this case degrees. It was in radians. So I'm in degrees, so I'm going to use the cosine button, and I'm going to put 17. I told it it's in degrees. So I should get, or you should get, 0.96. It said to round to 2 decimal places. So I get 0.9563. Let me write the whole thing out for you. 0.956304, which is 0.96 when you round. Now for B, I'm in radians, so I need to go back, change my mode to radians. So now I'm going to go sine, make sure you use parentheses, and please make sure you use the pi button. So I'm going to put sine, parentheses, pi divided by 12. So the pi button divided by 12, close the parentheses. And I end with 0.258819. 2 decimal places is 0.26. You will need to make sure you practice this, please. The only time, though, you need to worry about the mode is when you actually hit sine, cosine, or tangent buttons. Otherwise, you never need to worry about the mode, you guys. So don't always think, oh, I have to use the different mode. I have to change my mode. Don't worry about it. But if you forget to check your mode when you're supposed to, you're going to be in a lot of trouble. All right, so that's going to wrap up day 1 of 6.2. And I will see you in class tomorrow with any questions you may have.